Hello, 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 hello. Can any of you hear me?
Yes, I can hear you.
Okay, all right. I guess you can see my screen.
Yeah.
All right. So that's the class work. In the next 5 minutes, or maybe 10 minutes, when it's 11, 5 minutes past 11, we'll start. You should finish in the next 10 minutes. Oh, hello, Finn. Who can hear me? Who can hear me?
We can hear you, sir.
So,
Can hear you, sir.
all right, good. Who has finished? Who has finished? Sharply, don't let us waste time. Who has finished?
Oh, no. Oh, God.
Eh? You people went to do election and you forgot. You've forgotten everything, right? Okay, this is just revision, right? Let's go. Let's look at the solution here. You guys are still seeing my screen, right?
Yes, you can see, sir.
Okay.
Yes, sir.
All right.
Excuse me, sir. The breadth, that's the B, is 81.7 and the width is 55.4, sir.
Why did you get 51? Okay, let's see if you're right. Oh. Okay, look at the solution now. Okay, I guess you can see, you are seeing the screen, right?
Yes, sir.
Yes, sir.
I want sharp answer now, Finn. You leave your mic open, Finn, so that you can be responding, right? So,
Okay.
good. See the solution. First of all, when you have a question like this, the best thing to do is to list out all the parameters that you have. List out the ones you have first. You now list out the ones that you do not have, that you want to find. Effie, and be answering me.
Yes, sir. Yes. Oh, yeah, I'm with you, sir.
Okay, good. So now, we have all this. We have the length, we have the compression perpendicular to grain, we have the Young modulus. But meanwhile, this question is what is complete. Okay, let me see, what do we have? Young modulus, okay. Young modulus, okay, let me just fix it here. But subs in maybe in the CA or exam, in some questions then, you will not have Young modulus and compression will not be given to you. You are expected to use a table. I guess I've shown you guys the table now, right? Have I shown you the table?
No, sir, I don't think so.
I have.
No, sir. Nothing
People have forgotten everything.
in the lecture, sir.
I guess I gave you people the table anyway. Okay, so now we have you write out your length, you have your compression perpendicular. Why is it compression perpendicular? Why is it not a compression parallel to grain? Who can tell us? Fee, you are the rep. Answer me. Back.
Sir,
Why
I don't have an answer to it. Another person can answer it. I really don't know.
How can you say you don't have an answer? You've forgotten. I said compression perpendicular means what? It is a beam, right? Because the beam that carries load perpendicular to grain, load horizontally. The beams are installed what? Horizontally. So it carries load what? On a horizontal surface, on the across the length of the beam. While what? If it is compression parallel to grain, if we look at a piece of wood, you see that it has some lines like stretch marks on it, right? Fee.
Yes, sir.
What are you doing? Why are you not concentrating?
I'm concentrating now with you so I can see the screen, everything. I'm not doing anything.
But why does it take you time to respond now? Eh?
I'm trying to boot, that's why.
Better boot to a beg, right? When you see a piece of wood, if you look at the surface of a piece of wood, the one that is neatly cut, you see lines like stretch marks on it along the length of the wood. So if a load is acting perpendicular, means what? It is what? A beam. But if it is acting, if you install the beam, the wood, the timber or lumber vertically, and it is carrying load on the square or the horizontal face, it is what? A column. But Young modulus is the same for all. And the strength grade, the strength group is same for everything. So the best thing, what you should be expecting is a question will be given to you. Are you seeing? I hope you are still seeing my screen, right? You will not be given. You will not be given the only thing you'll be given here will be, assume this thing is gone. You have the length, you have the strength grade, the strength group, and then the grade. You have only that, the load, you have the load, which is your P. And then you have this one, this condition. Right? Then go me. Yeah.
Yes, sir. Yes, sir. Yeah, with you, sir.
All right. So what did I delete before?
You deleted Young modulus.
Okay. Why can't I highlight this? Oh. I want to bring this in back. Okay. Load. Okay, good. So the question says what? A wooden beam of length 3.6 meters. If you look at so from the solution here, you see this 3.6 meters is converted to what? To millimeters squared. Why? Who can tell us why? Look at the parameters that we have. Who can tell us why we need to convert it to millimeters?
We need to convert it to millimeters so
because
that,
most of the other parameters are in,
Yes.
they are
Yes.
millimeters.
Newton per millimeter, right?
And compression perpendicular to grain, they are also in millimeters, sir.
Exactly. But do you know what? You can as well decide to convert the compression perpendicular to grain to Newton per meter squared, right? But choose whatever is good for you, whatever you can work with, right?
okay, sir.
Good.
Yes.
So it now says what?
Yes, sir.
It says a wooden beam of length 3.6 meters and a square cross-sectional dimension. Look at this thing. Square cross-sectional dimension BD. Square cross-sectional dimension BD, right?
Yes, sir.
Is simply supported. So who can tell us? You know, I've highlighted square cross-sectional dimension. It means that what? Who can tell us? Who can tell us? What does it mean? What does that mean?
That's the area, sir.
Area is squared.
What does that? It says BD. It says square cross-sectional. It means what? It means B is equal to D. Yes, B is equal to D. B is equal to D.
Yes, sir.
Yes. Is simply supported at its ends, given that the wooden beam is sewn from strength group N6, right? Grade 63. Let me look for that table. I've shown you guys that table now. I'm showing you the strength group table. We don't forget this too much, huh? Let me see, strength green. Okay, good. Oh, good. Okay, let me share this again. I guess this is it. Yeah. Good. Can you see this? Have I not given? I've given you this table now free to give others. Have I not?
No, sir. This is the first time I'm seeing this table.
Oh, see you. This is the first time. I told you guys about this table before now. Look at it. We have two tables here, table 1 and table 2. Table 1, the title is what? Stresses applicable to timber with what? A moisture content greater than what? 18. And the second one is what? Stresses applicable to timber. Oh, wait the second one. Stresses applicable to timber with a moisture content of what? 18. So usually above greater than 18 is used. Why? So that if it loses more moisture in service, it will not bend, it will not twist, or it will not cause a deformation of the structure. Do you get?
Yes, sir.
Yes, sir.
Okay. So now the question says what? Wait. The question says what? Strength group N6 and grade what? 63%. Let's come to the table now. I'm showing you now so that nobody will come and talk. Good. Strength group what? N6.
Yes, 6.
N6. And how many percent? Grade what? 63.
63%.
So you now look at the table. This is where you're going to pick your values. You have your compression perpendicular to grain You look at it down the table like this, is 1.4, right?
Yes, sir.
Your share parallel to grain. You have no business
Zero
with share.
point-
You have no business with
zero
share. So share anything parallel to grain. It is what? Column. You guys should get this thing, oh. Wherever you see parallel to grain, it means you are talking about what? A column. Because in the question, you could have a structural member carrying load parallel to grain. There is no column in the question, no. But that word, those two words, parallel to grain, has automatically said what? You are designing for a what? A column.
Column.
So do not expect to see traditional questions. What is design a column whose B and D are so. No. You see a structural member carrying load parallel to grain. A structural member carrying load perpendicular to grain. That's why you should know these terminologies, right? And
Yes, sir.
you can see that your modulus is the same for all the strength groups for a particular strength, but different grades. A particular strength group has with different what? Grades, strength grades. You have 80%, grade 80% is better than 63, 63 is better than 50, 50 is better than 40. But all of them have the same what? The same young
Modulus.
The same,
now, this young, look at this here. This strength grade here now, which is in percent, is just like you have female, male, this. They are all what? Human beings. Are they not?
yes, sir.
Or you have people with different heights, 80, 63, this, but everybody is what? It's a human being. That what makes them what? They have the blood. Their blood is the same thing, right? That is young modulus. Young modulus is same for all the grades. Oh, let's go. Let's go back to the question. So that is that. And then supporting the concentrated load of what? 10 kilonewton in magnitude. Determine B and D. Maximum deflection, if permissible deflection is this. Maximum deflection, if permissible. Look at these words again. Maximum deflection, and then permissible. Permissible is what?
Allowable.
Allow. Maximum, look at it. Permissible is what is given to you. Maximum is what you are asked to calculate. Do you understand?
Yes, sir.
Your own is where you see maximum deflection. You are the one to calculate. There's a formula for maximum deflection, but permissible. That is that is beyond maximum. What can be allowed? What is allowed? Permissible is the same thing as what? Allowable deflection. Do you understand?
Yes, sir.
You can just, it's common English now. Who allowed you to go out? Who permitted you to go out? Right? Now, maximum share, if permissible share is this, and your modulus is this. Okay, let's go. What is this? All right. So now, let me ask you guys now, look at this. If you look at this question here, look at this question here. The question says what? Cross-sectional, square cross-sectional dimension. But the condition here says what? D is equals to 2B. Is it correct? What should be the condition?
Sir.
Is it correct?
D is equal to 2B. It's supposed to be D is equal to B or B is equal to D.
Correct. Where is this thing? Or B is equals to what? D. That's 0.5 marks for you, Faye.
Thank you, sir.
So, our time will soon in the next, we still have 15 minutes. Okay, no problem. So, the first thing to do is what? Maximum moment, which is this. Okay. You calculate your maximum moment. After calculating your maximum moment, let me write it here. Maximum moment. And then, after calculating your maximum moment, you determine your sectional modulus. Your sectional modulus, which could be is either Z or S. Huh? Are you guys following me?
Yes, sir. We're following you, sir.
Good.
Yes, sir.
Who wants to talk? Okay. So there's one important thing you need to know now. Do not forget. Do not forget this. Look at this equation here. Let me get this equations out so that. Oh, why is this thing? This thing should not waste my time. Okay. Okay. Let's just go. Look at this equation. FC. FC is what? Let me put all these things here so that FC is what? Compression perpendicular to grain. FC, that is the given FC. The FC you are going to get from the table must be greater than or equal to your what you have here. If we do this, somebody should do this in quickly for us. M max, Finn, somebody should do this in quickly for us. Somebody should do this quickly for us. It says M max divided, what's the unit for M max? Newton millimeter, right?
Yes, sir.
And then what's the unit for section modulus?
Section modulus.
Yes.
Millimeter
Should be
cube.
Eh?
just meter.
Millimeter cube.
Millimeter.
BD squared over 6. BD squared. That's millimeter cube now. Is it not?
Millimeter cube. Yes, sir.
Okay. So now divide Newton millimeter by millimeter cube.
Newton per millimeter.
That's Newton
Newton
millimeter.
per millimeter, Abi?
Yes,
Per
sir.
millimeter squared.
Yeah.
Is it not?
Yes, there's a square
Yes.
cube
Yes,
and
sir.
just one.
Is it not correct?
Correct. Newton
Sectional
per
modulus.
millimeter.
Okay. Have you forgotten 6 sectional modulus here? The units.
Newton per millimeter square.
Yes, Newton per millimeter
Good.
square.
Good. So you see that this FC, this one is saying, why is I cannot see the cursor in this equation here? Why? Okay, let me just write it somewhere. Hey, what's going on? FC must be greater than or equal to. I want to write an equation here to show you people why FC. Good. When you want this thing to respond, and that's when you start this. Okay, FC, F subscript C. Oh yeah, now fast. Okay. Huh? What I want to show you guys here, so that This is the basics, the foundations. If you know this one, you'll be able to solve any question relating to any question on beam design. Okay. Ratio greater than or equal to FC to be greater than or equal to F max. Good. FC is what? Compression perpendicular to what? To grain, right?
Yes, sir. Yes.
Okay. And what? F max is your calculated F. Is your calculated what? Compression perpendicular to grain. And it's saying that what? It must be what? The calculated one must be less than the tabulated one. That's the one from your
Yes.
table. Okay.
Because everyone must be less than the calculated.
And your F max, you guys get this thing now. I hope you're following me.
Yes, sir.
Following you.
You're trying, sir.
You should try hard. If no matter if at all it's only this thing that we're going to do today, no problem. I wonder why this thing is behaving like this. I can't see the cursor anymore. Okay, let's continue. Whenever you start to respond, So now, look at this. So FC must be greater than or equal to what? F what? F max. And your F max is equals to what? Maximum moment divided by what? Sectional modulus. Understood?
Yes, sir.
That's clear, right?
Yes, sir.
Good. So, and this is it. So that means your 1.8 must be greater than or equal to these values that you have here.
Okay, sir.
Divided by BD squared. You don't know your BD squared, right? And that's what you're looking for. So once you get to this point, best thing, the next thing to do is to do what? Multiply through by BD squared. And then you will have this equation here. Right? You have this, right? And then just make your BD square your substitution of the formula by dividing through by 1.8. You have this. Good. This is where Wahala starts. Yeah? Now, let me show you one table. It's a table for trusses, basic size. Good. I've given you people all these things that you feel saying I did not give you. Let me send it now before that I will not. If is that I said I will send before I forgot. Let it not be that I forget again. Yes, one. And strength properties and sizes. Good. So just forward this to them afterwards. Let me open this.
Okay, sir.
So very good. So now you are designing for B and D squared, but there is a table that guides you in the selection of the sizes of the size B and size what? D. You don't just assume any number as you like. You don't just assume this table. Finn, can you remember seeing this table? So you can't remember.
Um,
Go. Look
I'm
at
not
this.
sure.
It's okay. It's okay. It's okay. Look at this now. Thickness. And then you have the width. Thickness is what? Thickness is your D.